Agricultural Research, which is based in FAO, yes. And what I'm going to describe here is the challenges that we found, especially the semantic challenges that we found, while we were trying to create a faceted, yes, curated and federated catalog of data sets. So we are not just indexing data sets, but we're also federating data sets from other existing catalogs. Okay, is this? Yes. What are the aspects, the various dimensions of semantics when you want to describe a data set? This is a diagram that I built based on existing vocabularies, existing RDF vocabularies. I'm considering only linked open data vocabularies here, since the conference is about linked open data and this is about semantics. There are other vocabularies which are not RDF to describe data sets. But this is based on 3 or 4 existing vocabularies that are very much used to describe data sets. It is not about the data, it's only about the metadata about the data sets. As I say there is no existing universally accepted vocabulary to describe a data set. Each of the existing ones describes better a certain aspect of the data set. As you can see here, I make this distinction between value vocabularies and description vocabularies. It's not my description, it's what also the W3C adopts. And I find it very convenient especially for one reason, because what I'm going to say later in the presentation is that one of these types of semantics is easier when you want to aggregate from different data sources. The other one is much more difficult. So starting from the description vocabularies, there is, for instance, for the dimension of the data set as an intellectual product, as a resource, there are several vocabularies that describe that. You can even use Dublin Core, but then there are specialized vocabularies like DCAT, and both the void vocabulary, but also the data cube vocabulary. They cover all the basic metadata about the data set. So who's the author, when was the data collected, where, also licensing, metadata, there is everything. But more specifically for data set, and this is something that is not covered by all vocabularies, but is covered by DataCube and also by another extension of the DCAT vocabulary that's called StatDCAT, is the description of the structure of the data set. Because without that, you cannot do much with the data. If you don't know which dimensions are described in the data set, what are the phenomena that are being observed, and the units of measure, etc. These 2 vocabularies cover that. And then the other object, let's say, that has to be described is the actual serialization of the data. So what is called distribution in the DCAT jargon, but it's basically a file serialization. You can have more for each data set. And the basic metadata that you need there are, of course, where the file is, so the URL where you can download it. The format is essential, and this is something that's very challenging when you want to aggregate data sets from different systems. They don't always indicate the format in the same way, of course. But this is about the description. So description vocabularies, they give you the metadata that you have to use to describe the data set. When you go to the values, the actual values that you use for this metadata, this is actually the big challenge, because in most cases, these vocabularies would require URIs, so concepts coming from existing vocabularies. This is not always applied when you use these standards, because there aren't any reference vocabularies for certain things, so you have either to create your own, or in the end you end up using strings. Or because maybe the tool that you're using doesn't allow you to do it. But for instance, for topics, in the agricultural sector, we might want to use AgroVoc. You cannot always do it due to the tool that you're using or other reasons. Very quickly about value vocabularies, and this is, to me, the most challenging aspects of semantics, because the description, the metadata can be different, you can translate very easily. While in this area, in the values, the problem is, in some cases, okay, you use string because you don't have your own vocabulary, or you use local URIs because you have not mapped to external URIs, which makes discoverability not very easy. But the main problem is, for many of these classifications that you would need, controlled values for your metadata, there are no existing agreed, shared vocabularies. This is, for instance, these are examples of vocabularies that you may want to use when you want to use controlled values and URIs that everybody can refer to. Some of these exist. We know that for our area, for the thematics, for the topics, we have AgriVoc. If you want more specific vocabularies, only crop names, you can use the crop ontology. You have also some classification specific for soil types, etc. There are also vocabularies that are not really specific for the domain of agriculture, but that you may want to use if you want to indicate something univocally, like an institution, geographic names, or spatial data. Particularly challenging are file formats for which there is no official vocabulary, but you can maybe take the URL from existing authority organizations. There is nothing, for instance, if you want to indicate the type of data that your dataset is managing. So either you have your local classification, many data providers have their local classification of data types. You can also find some authority organization for the list of licenses and other things. So these are all value vocabularies that you may want to use when you describe your dataset. What we wanted to do was, the challenges came up because we wanted to build a federated catalog of datasets. So harvesting from several existing catalogs. And what we built was something that's actually mixed. It's a federated catalog. It's also a primary catalog where you can catalog and upload your dataset if you want to. But in most cases, institutions don't want to do that. They want us to harvest from their existing catalogs. At the moment, we have these numbers of datasets. The datasets are those that give actually access to a file in the end. The data services are something where you can find the URL, and then it's up to you to find the actual URL of the dataset. And we are harvesting from these catalogs at the moment. They use the reason why we chose this is that they use standardized tools like Dataverse or SICAN, so it's not so difficult to harvest. But there are still a lot of semantic challenges. The semantics that we use in the ring are what I described before. We use the three vocabularies that I mentioned: DCAT, DataCube, and Void, and we try to standardize also the values. So whenever possible, we use something existing, like AgriVoc or the geopolitical ontology. When something is not existing, we build our own SCOs. We make the URIs public, and whenever we can, we map to existing URIs outside. The last but one point is data standards. There is no data catalog that classifies datasets according to the data standards that they use. In another project that's called Golden Action, we built the Agri-Semantics map of data standards, which is also a linked open data, so you have a URI for each data standard that we collected so far in the map. And we are using those URIs in the link. At least we have something that is not really local. We're looking outside. Examples of how the data sources are. So if you harvest from a SICAN dataset catalog, you have the metadata using DCAT, so it's RDF, it's DCAT, and everything is okay. The problem is, again, it's not the metadata format, but it's the values. So in most cases, they have strings, because the tool makes it difficult to use URIs in the interface when you catalog datasets. So you have strings for the topics, for the geographic coverage, also strings for the format. Even more difficult example, this is not even RDF, this is XML, it's what Dataverse exposes. But as I said, it's much easier to match the properties of the XML to actual RDF properties. That's very easy. The values are again the problem. So strings for geographic scope, for the keywords. This is actually very advanced RDF. There are also problems when the RDF is very, very good, like the European Data Portal. They have URIs for everything, but they are local URIs. They are on SCOs, so you have to then do more queries to understand what those topics are. And this is what we do in the CR3. Basically, we want to solve this issue. We don't want to use keywords, because then we re-expose all the data as RDF again for other tools. So we try to transform whatever is in strings in the source. We have an internal database with a lot of synonyms for all the control terms that we use. So matching the keywords, partial matches between the term and the keywords, and we manage more or less to match it to controlled terms, which in turn are linked to external vocabularies. So we can transform simple keywords into an actual RDF resource. And this is especially important when we want to map to vocabularies like AgriVoc and FAO. So what happens is a simple keyword coming from an external catalog becomes a URI and is immediately mapped to an AgriVoc or to a geopolitical ontology URI. And we do all of this because we want people to be able to do queries like this. You don't need to know what our internal URI for Uganda is, or you don't have to use the string. You can use the geopolitical URI, and you get all the data sets that have have data about Uganda. Same thing, you don't need to know how we name the concept of livestock, or if we have an internal vocabulary, so you use agrovoc, and you get all the data sets. And same thing with this new data source that we have, which is the Agri-Semantics Map of Standard. If you want to identify a data standard, we have unique URIs for each data standard, and you can get all the data sets that use this. This is all not because this is actually the end objective, the final objective, because we don't want people to run SPARQL query or to be able to write SPARQL queries. This is for other applications to build upon. So there is a user interface of the website where you go and you search for the data sets. And there is a machine interface for other applications that want to build on this and want to learn if there are data sets on a specific topic, on a specific country, with a specific type of data and using a specific metadata standard, for instance, data standard. And the conclusion, this is the last slide, anybody? These are just some links. The conclusion for me is that the most difficult, the biggest challenges are not so much about the RDF vocabulary, the description vocabularies you use, but the value vocabularies, so KOS, agreed KOS. And the other challenge is the tools that that data providers are using, that not always allow them to use the semantics in the best way. Thanks.